Okay. So 4.1, let's begin chapter 4, and then after we have questions about the review or whatever, we can do that. No big deal. Um, but chapter 4 is about applying the derivative. So using the ideas of tangent lines, knowing that right here my slope is increasing, down here it's decreasing. But right here it's equal to 0, and over here it's equal to 0. So knowing that the tangent line slopes are 0 here and there, then that means we can find the location of maximums and minimums. So we find these critical numbers by setting the derivative equal to 0 and solve for x. So those x values will be the location of where your function has a zero derivative, which is also a max or a minimum. Okay, that's the idea where we're going. So first thing you do, this is number 3 from your homework. Double check the question.
Sir, you said this is 4.1, question 3?
Yeah.
Okay, thank you.
Second. Actually, question 5.
Okay, all good, thank you.
There we go. But let's go ahead and look at the first couple before we get to this one. Where is the share? Can y'all see the homework questions?
Yes, sir.
So a couple of places where you have um, extremas or critical numbers are going to be values that are cusps. See how it has like a sharp kind of edge? So there may not be a derivative. In this case, there is. But sometimes you have an x value that you can plug into the original function, but not the derivative. So those values can be a possibility of critical numbers. So in this one, what you would do is take your derivative of this, right? Do a quotient rule or whatever, then plug in 0, and then you should get 0. Okay. And you should see it right away. This has a decreasing derivative all the way down. Then right at 0 it begins to increase. So that implies that there's a 0 here for f prime. Okay. So check this out. See these peaks and valleys. The derivatives at the peaks and the valleys are going to be 0. So they're asking you, knowing that 0 is right there. So the derivative should be 0 because it's going to be a peak. So if you found the derivative and plug in 0, you're going to find out that, yeah, the slope is in fact, well, you see what I mean? That's why you don't have to actually do anything. If you understand the concept, that's going to be 0, like, no matter what. Okay, but if you didn't know and you took the derivative, plugged it in, you better get 0. This is the cusp for sure. Okay, this is the one I was talking about earlier. So basically, if I cannot plug in the value into the derivative, but you are able to do it into the original, then it's a critical number. So notice right here, if I plug in -3, you would get -3 plus 3, which is 0. 0 to the 2/3 is 0, right? So no problem. But if you take the derivative, you're going to have x plus 3 uh, at the bottom would be what? -1. X plus 3 to the 1/3 at the bottom. So this will no longer be allowed. Well, you can see it on the graph, so you don't really have to do that. But you should be able to. You've done a bunch of them for chapter 3, right? So at this point, I'm assuming, so is chapter 4, is assuming that you're a pro at derivatives. So if you needed to find f prime and plug in -3, you could. By seeing the graph, you should see that this is really sharp. So the derivative will not be defined at -3. So it should not exist because it's so sharp, right? They call that in the book a cusp. Okay. And when you take the first derivative, you will see obviously why. All right. Let's see here. All right, so we'll get to that just right in a second. So, so a critical number is a potential maximum or minimum. They are values that are either making the derivative equal to 0 or make the derivative undefined, assuming your function can accept that value. Okay. Where's the damn thing? Oops, forgot.
Thank you, sir.
Oh, you good? Oh, there it is. Nope. Oh, I have too many cameras on this thing. Okay. All right. So here we have a maximum. So the critical number would be the A. Here we have a minimum. So the critical number would be the X value that corresponds to this minimum. That's what it means. That's what this means. Now, it's not always going to be the max or min, but it is a potential. So you're going to want to find these because they make the derivative equal to 0. And usually that happens when you have a min or a max. Okay, usually. All right, so first question, the number 5. Let's just practice finding them. Okay. Okay. So step 1, in order to find them, is find f prime. So what is my first derivative? What do y'all are pros at this point? You just took test 2, I assume, or about to.
It's gonna be 4x to the third minus 3 times 8. That's gonna be 24 to the x to the 2.
Yeah. So there it is. So now step 2, set f prime of x equal to 0 and solve for x. These solutions will be your critical numbers. Right. So remember, we're trying to find them because they could be maximums or minimums. So in real life, if you want to maximize profit, minimize waste, you know, maximize some sort of efficiency or whatever, that's when we start to care, right? But first you understand the theory. Basic theory is given any function, right? Whatever makes these derivatives zero, we have potential mins and max, which the book calls extrema. It's a general term for either or, right? They also call it, yeah, so global max is like the absolute maximum, global minimum is the most minimum. Local min and max would be these here. So if you saw the lecture, right? Notice how this function goes on forever, right? So the maximum doesn't exist, it's infinite. So we have a local max here. Minimum goes down forever, negative infinity. So we have a local minimum here. So these are extrema values, but not global maxes or mins. They are extremas, local max and min. So if you see in the homework them using that terminology, that's what they mean. But you can just think of it as peaks and valleys, okay? All right, so set it to 0. Solve for x, here we go. Factor 4, is 4 one in both? Right. Okay, so set each part to 0. X is 0, x is 6. Okay, so these two values are your critical numbers. Any questions on how to find them? That's all you do. You take your derivative, set your derivative to 0, solve for x. Nothing crazy, right? Okay. Let's do another one, but this time we will find the extremas, the max and mins. Number 8. Notice that if they um, close up the function on a specific interval, then you will have a max and min, a absolute max n. Find the absolute extrema of f of x. F of x is equal to, let's do number 9. That was kind of boring. Number 8 is too easy. Number 9 is x cubed minus 3/2 x squared on this interval. So they're saying find the highest value and the lowest value from -1 to 6 on this graph or this function. So step 1, Find the critical numbers. And we said that the first part, we'll call it step I guess, is find the derivative. Derivative will be 3x squared minus 3x. Step 2 will be find, make a little note here, find f prime. Second part of step 1. Set this to 0. That's what we said last time. Solve for x and we get x minus 1. So 3x is equal to 0. X minus 1 is equal to 0, giving us two critical numbers. Okay. Yeah, cool with the derivative and the algebra. Any questions about that before we go to the next step?
Sir, for me, it's just the derivatives, but I'll talk about it with you later. But
Nope.
these are easier. It's just the fractions.
Yeah, think about it this way. Derivative of this, right? You bring the 2 down. The 2 cancels this 2. So you're left with the 3, and then you subtract 1. So basically this is the step I didn't show. You bring the 2 down, 2 minus 1. You see what I mean? That's what happened to this part here.
All right, I'm gonna take a picture.
Uh-huh. So we're just doing the power rules. That's all. It's just that the power rule is being multiplied on a fraction. So so it'd be 3/2 times 2. Two. So since it's on a closed interval, this is the process. You're going to test x equal to 0, 1, -1, and 6 by plugging them in. F of x, the biggest output will be the max, the smallest output will be the minimum. So in the book, there's a theorem that says if we're looking at a closed interval, that the maximum and minimums or the extrema are going to occur at the endpoints of your interval or your critical numbers. That's where these numbers, that's why I chose these 4. I chose the two critical numbers and the endpoints. That's all you're doing. You pick all those and then just plug them in and see, okay, what's bigger? Find out. All right, so here we go. Plug it into the original. F of 0 is equal to 0 cubed minus 3/2 times 0, which is 0, right? Now plug in number 1. That'll be 1 cubed minus 3/2 times 1 squared, which is 1 minus 3/2, which is what? Negative half, right? Okay. Man, my elbow hurts. Okay. Next number. F of -1 will be -1 cubed minus 3/2 times -1. This will be -1 minus 3/2 times +1. -1 minus 3/2. What is that going to be? Is that 5/2? Right? Right? Number 6, the last number. Plug in 6. We get 6 cubed. That is
36. Right? Wait.
6. 6 times 6 is 36.
Oh,
36 times 6 is what?
I don't
So
know.
one more time, right? I think it's 216. Is that right, guys? Check me on that.
Wait, you said 36 times. Okay, yeah.
See, right? 6 times 6 times 6, which is 36 times 6, which is 216, right?
Yes.
6 times 6 is 36. Half of 36 is 18 times 3. I don't like numbers. There we go. So, okay. It's totally fine to use your calculator at any point. It's not a big deal. Yeah. This is not arithmetics class.
You
All right,
say
so now, oh, go ahead.
18 times 3
Yeah,
supposed to be 54. No?
54.
Yep.
This would be 216 minus 54, 162.
I got it.
That good or no?
Yeah, it's good.
Okay. All right, so what's the biggest, right? Maximum at 6, comma 162. Minimum at, looks like this -1 here. So because it's closed, we can find the absolute extrema, or which is another term for global extrema, same thing. So if you're watching YouTube videos or reading different books, it's all the same. Global, absolute, whatever. So we can use this technique only if it's closed on an interval. Okay. Any questions on number 9?
I have a question.
Mhm.
Were the two limit numbers or excuse me, not limit, the interval numbers, are those considered your critical numbers as well, or
No,
is it just where it's 0?
no, there's a theorem that says that if you have a closed interval, that max extremas can occur on the endpoints. So you got to check.
but they're not critical, or are they?
No, they're not by definition critical numbers. Critical numbers were
Gotcha.
found up here, right? Because these made the
So-
derivative. So
Yeah.
that's what the critical number is. So these could have been the max and min. It just so happened that the endpoints ended up being max and min. But you got to check all four to see. You got to check all of them to find out.
Is the critical numbers only where the x is 0? Or I mean excuse me, the slope of the function being 0?
Yeah, pretty much. That's what a critical number is. But um, is defined as the number that makes your derivative equal to 0, the x value. The other definition would be the number that is defined in the original but undefined in the derivative. That's the other spot it could occur. But mainly you look at the values that make the derivative 0. Any questions on number 9 here? All right. You want to do one more of these?
Yes,
Yes.
please.
I think we should. Do one more and then we'll move on to another section. So first step, find critical numbers and then plug them in, see what's bigger, and the endpoints. Doesn't sound crazy, right? The same question, just different function. Let's do a trig function this time. Let me see what question this is.
Eleven.
11.
I have a question.
Mhm.
How trig heavy is the test?
Not very.
Should I make notes of the unit circle?
I mean, you can bring the inner circle with you. It's not a big deal.
You're all right if I print it out?
Yeah, that's fine. I mean, you should know it. I'll judge you a little bit, but you can bring it
I got you.
if you need it. I understand. Okay. Now, but you should have also the derivatives of trig functions. So make sure you have that too. The one I sent you, do you remember?
Yeah. Can we use that on the test?
Yeah, that's fine.
Cool.
I prefer you understand than memorize. I don't think math is about memorization. Kind of why I prefer this subject.
What about some of the rules for trig functions?
Which ones?
I think this question or one of the other ones that um, used one of the lesser known or sorry, less common. Heck, what was it?
Derivatives?
It used the double angle formula. So it was like 2 sine theta cosine theta as sine 2 theta. I
Did
think.
it come up in your homework?
Yeah, but it turned out not being necessary because you needed to fully expand it anyway. I just recognized it as a formula, and I was like, "Oh, do I need to use this here?"
I mean, you can always use them anytime, but yeah, you're right. It's not, it may or may not help you, you know. There might be times where using the identity will simplify your question, and there'll be times where you shouldn't use them. But I don't think in calculus one, we're not gonna be identity heavy, if that's your actual question. In Cal 2, there will be. They're gonna expect you to remember all your pre-cal.
Sir, when is the test? Next test?
I think it's been open for a while. I don't know when it closes though. I'd have to check. I'll check in a bit. But let's finish this first. What's the derivative of f?
-3 sine x.
Yeah, -3 sine x. So there's step one. Step two, set this guy to 0, right? When is sine equal to 0? Y'all remember your unit circle?
It was it 1/2? No, I don't know.
There's one of the, it was like pi or something, stuff like that. Pi over 2, remember all that?
Sine is the y's, so it's 0 and 180 degrees, which is pi, and then 2 pi, which is 360 degrees.
Okay,
Yeah.
thanks.
Yeah, so that would be all on your unit circle, right? So if you don't remember, please print one out and look at it. Okay. So step 3, plug in x equal to 0, pi, what else? 2 pi. To find the max and min. Yeah, I think the syllabus says this should be done. Exam 2 should be done this week, but I left it open longer. No, this is chapter test 3 stuff. We're just starting test 3. I waited to start this so you can do chapter 3 in practice. I'm hoping that your chapter 3 is done at this point. And if not, please get that done. So cosine of 0 is 1, right? On the unit circle. 3 times 1 is 3. What is cosine of pi?
-1.
Yeah, -1. Okay. What is cosine of 2 pi?
1.
1. So 3 times 1, 3. All right. What's the biggest?
It's a tie.
True.
Awkward.
Yeah, you know why that is?
Because it's sinusoidal.
Yeah, you said this is number 11, right?
Yeah.
So it has two peaks basically. It keeps going forever, so it's going to keep hitting peaks over and over again and valleys forever. But if we close it off on 0 to 2 pi, you'll have a couple, right? So we have two maximums and a minimum. So maximums and 0, 3 and 2 pi comma 3 minimum. Oops. Pi comma -3. Any questions on this problem? We'll move on to another section. So I'm going to skip 4.2. I'm not going to test you on it, but I do want you to go over it on the homework and watch the videos. I'm going to move on to 4.3. This is the first derivative test. Let's see. Yeah, we got time. Hold on a second.
Could we go over Newton's method?
Yeah, we can. Yeah, one in particular, or do you want me to pick a random one?
You can pick a random one.
All right. So in the homework, let me show you the homework makes it look harder than it really is. Yeah, check it out. Can you see the problems? So here, what they're doing is doing piece by piece by piece, which makes it look complicated, but in reality, you could do it all at once. So it's an iterative method, which is basically kind of how programming works, right? You find the first part and you create a formula and you loop it around 100 times or 1,000 times, and eventually gives you a good value, right? So um, what Newton's method is doing is approximating your zeros. So kind of, you know how when you have a TI-84 or whatever, you have your graph, you can find your zeros on there. So it's most likely using a formula like this. So the first thing you got to do is take your derivative, right? Plug in the x1 you're starting with. That gives you this first part up top. Plug it into your derivative, you get the bottom part, and then this would be your beginning point. So let's go ahead and do, I guess the first one.
Is there a limit to what your starting value can be?
No, Are you wondering if it matters?
Yeah, like is it always going to approach the closest zero or the zero to the left or the zero to the right or what? Like how's
Oh,
it
I see what
move?
you're saying. Yeah, it'll find the zero that's closest to the number you choose. So if there's multiple zeros, then yeah, that could happen. That's when you need to find like that's when you have like you need to look at the graph, right? So if you see it going up and down for a while, then you gotta choose, okay, well, I kind of know where it's at, somewhere between, I don't know, 3 and 10. I'm gonna choose something in there, and then that'll get close to it. But in these examples, I think there's only one zero, so it doesn't matter. But this one has multiple, right? Number 3. So it's gonna find the closest one to 0.7. Can y'all see me opening this web page?
Yeah.
Like just for experimentation here, let's graph cosine x, right? And they're choosing the x value 0.7, was it? Yeah. So closest zero to here is going to be there, right? Pi over 2. But what is pi over 2? About 1.57. So if I pick 0.7 as a do multiple iterations, I'm going to approach 1.57, which is right here. Does that make sense? That's what this is doing. You see how it's getting closer and closer? In my first step, I'm at 1.88. My second iteration, I'm almost there. So if I go again, I'll be very close to 1.57. But they'll tell you how far to go. Like just do two iterations and then look at your decimal places. So let's go ahead and do one. Let's do number one and prettier answers, kind of. I don't know. Switch over. I've calculated 2 iterations of Newton's method. Oh, excuse me. So they gotta give you a function and they have to give you a starting point. Okay, so the formula is xn, how should I say this? Xn plus 1, meaning the next value is equal to the previous value minus the previous value at the function divided by the derivative at that same value. Okay, so the equation is using the initial one that gives you the next one. But then once you find that, you plug it in there and you find the following point, then you can keep doing that. So this is something that we usually code because it's annoying. It's actually a really fun intro programming problem. Okay, so we're gonna do x1, right, which is 2. I'm gonna find x2 using x1. So I'm gonna need the derivative, right? So take your derivative real quick over here somewhere. There it is. Now plug in everything. I'll do it down here, I guess. X1 is 2, so 2 minus f of 2 over f prime at 2, which will be 2 minus 2 squared minus 5 divided by 2x, or 2 times 2. So that'll be 2 minus 4 minus 5 over 4. So 2 minus 4 minus 5 is a negative 1, right? So negative 1/4. Which is plus 4th. What is 2 plus a 4th? 5/4, right? But before we go any further, any question on what we just did, right? We used, oops, I'm blurry. We use this formula to find the next value. We're trying to approach the 0, or the value that creates 0. So, yeah. X1 was given to us, we found x2. So we plugged it in to the function and the derivative, that's the formula, so there it is. We find out what that becomes, we get some number. So here is x2. So plug this again into the formula to do the second iteration. Do you have any questions on the first iteration? Okay. But in the homework, what they want you to do is piece by piece. So notice they have this top part by itself, right? That's the second piece. That would be -1, right? At the top. Then they have the derivative at x1, which is 4. Then they have the ratio, which is -0.25. And then subtract the whole thing, which is 5/4, which is 2.25. So they're doing piece by piece on the homework. I think it's annoying, just do it all at once is fine, but they want you to, I'm not sure why they're doing that. I guess maybe to be careful. I don't know. But you see how it works, right? Or no?
Which one method was this? I was in, what
This
was
is Newton's method.
Newton's, right? Newton's. Oh,
Yeah.
okay. I see.
3.8.
Okay. Newton's method.
Yeah. It's an iterative method to find zeros. But you can't use it unless you know what derivatives are. That's why they never talked about it in college algebra, right? Step 2, second iteration. So x3 is equal to x2 minus the function at x2 divided by the derivative at x2. And we found x2 to be 5/4, right? So that'll be 5/4 minus the function at 5/4 divided by the derivative at 5/4. At this point, I would start using a calculator because this is getting pretty ugly. So that'll be x squared minus 5. So 5/4 squared minus 5 divided by 2 times 5/4. Yeah. So find all this nonsense. The homework will have you do piece by piece, so don't forget. Use my calculator. 5/4 squared. Oops. Minus 5. Oh, there it is. So this would be on the top, negative 55/16. 2 times this would be 10/4, which would reduce to 5/2. Divide this nonsense. It'll be negative 55/16 times 2/5. Right? So that'll become cancels with the 5, cancels with the 2. So that'll be negative 11/8. Yeah. So 5/4 plus 11/8. Which would be 21/8, right? The homework uses a bunch of decimals, so whatever. If you want, you can use your calculator. You will have at least one of these on your test, but it's just a formula, right? I showed a ton of extra steps. I mean, you can skip a few if you want. It's whatever. It's not a big deal. It is really a calculator kind of problem. Does the new method make more sense?
Did we do number 8?
Which section?
Same section.
Number 8. Interesting.
This one really confused me. I think the graph was weird. And I didn't really understand what we were aiming for. I guess just the 0, right?
Yeah, we are trying to find the 0.
No, basically you just look in the closest number.
Mhm. Interesting. Why does it fail? Let me see. Yeah, I see. Oh, right, obviously. Sorry, I'm tired. So this is why it doesn't work. Do you have, let me show you the graph. Can you see the homework problem?
Yeah.
So right here, do you agree that that's an extrema? And see how the slope is going to be horizontal.
Yeah.
So if the slope is horizontal there, and that's where the initial guess is at, right?
Mm.
So that's a value that makes the derivative 0. Now look at your formula. Where is the derivative? Right,
Where's the derivative?
we're dividing with by the derivative. Newton's method is x
Right.
minus
Right.
f over f
Yeah.
prime.
Yeah. So
So,
since my prime is 0,
right, if you choose an initial guess that is at an extrema, a maximum, a minimum, etc., then you can't use it. You can't find anything. You can't start the iteration. You'd have to pick a different. If you pick something below 1, you'd be fine.
but we have to start on 1, and because we have to start on 1, it's impossible.
Right. That's the
Mm.
explanation. That's why the method fails, because you end up dividing by 0, so you can't do it. Right, because Newton's method at the very top is right here. F prime is at the bottom. So I cannot have any x values that make the derivative 0, and we just talked about when does that happen? That happens at peaks and valleys, right?
So if we're going to use Newton's method, we should not use an extrema point.
Right. Do not use a critical number.
Critical number. Yeah. Gotcha.
So if you're trying to use it and you get an error or you see a 0, then just choose a different initial guess.
What I did, I just choose 0.99 and 1.1.
Yeah, it would have been fine. You could have put like chosen 0.5, would have been good. Those work. It's just we can't use this one because they told us to use this specific number, so I can't. That's why they said does not exist. You cannot continue. So it was more of a conceptual question there's no real work to do. Does that answer your question?
Yeah,
All right.
I almost understood it.
You mean before or right now?
Yeah, because I did the homework and I got stuck on it, but I kind of got it, but not really, but kind of. And I put the explanation in and basically just explained that it was because of the division by zero. So I got that far, but I didn't really understand why it really didn't work beyond just dividing by zero.
Right. Yeah. I mean that Newton's method requires division by the derivative.
I think saying I think answering the explanation with that because the initial guess was at a critical point would
Hmm.
have been been more proper. Mhm.
Yeah, that makes sense. Yeah, because Newton's method, yeah, has restrictions. So if you read the theory, the definitions, it'll tell you what's cool and what isn't. But yeah, that's a good question. Forgotten about that for a second. Yeah, you don't have any other questions?
Yes, when did you say the test was gonna be? I know it's open, but like until when? Until October 22?
Oh, let me double check. Don't remember. Yeah, I pushed it back to the 22nd. Mhm. So, I mean, I wanted it done by, no, yeah, that makes sense. 20 seconds is good. Yes, so you have a week to get it done. Little 8 days, I guess. No, this day's over. 7 days. So you have the review and then your exam. It's all chapter 3. And then it'll be very similar to your review. And I sent you the review on Remind, the YouTube link that I did a different semester.
Okay. Thank you, sir.
Yeah, but any other questions? Good. Well, we'll stop here then. Wednesday we'll do another section. I'll probably wait till Wednesday to do 4.3. And I'll ask one more time if you have any questions for test 2, okay? And then I'm gonna keep going. Let me take roll and then we'll call it a night. There. Is Dana here? Leandro?
Here.
Evelyn? Calzada? Adam Dobbins?
Here.
Astrid Lopez?
Here.
Simon Metz? Not here. Okay, Samar,
Here.
Brian,
Here.
Serena, Vivian. All right, guys. Oh, excuse me. I'll see you Wednesday. Let me know if you need anything, okay?
Thank you, Professor.
Have a good night.
Thank you. Good night.